ions. So far, all the examples I've shown you are ions that are made from either a single positive atom or a single negative atom. And sometimes they might combine in groups, but now there's another category of ions that we call polyatomic ions. They're a group of atoms that are bonded together like a molecule. So they're almost like a molecule, but then the molecule itself has lost or gained one or more electrons. So imagine if I could take a molecule, but then either give or take away electrons from that molecule, you would have what we call a polyatomic ion. So what that means, it's a group of atoms bonded together that the entire group has a charge. So these have very unique names. I'm not going to make you memorize them, but some of the names you might have come across. So a polyatomic ion is written like a molecule, but then after the formula for the ion, the charge is written after it. But the charge indicates the charge of this entire group. So for example, ammonia is made from a nitrogen that's bonded to 4 hydrogens. But this entire group collectively has a +1 charge. And we're going to refer to that as ammonium. Hydroxide is another example of a polyatomic ion. It's made from hydrogen and an oxygen atom bonded together. But then we give that molecule, a group of atoms, a single electron, and it becomes a negatively charged polyatomic ion. Okay. Nitrate and nitrate. So nitrate is an ion made from 3 oxygens and 1 nitrogen, has a -1 charge. Nitrite, notice the only difference is a single letter. The A becomes an I. This is NO2 with a -1 charge. And then remember we had nitride with a D, which is not a polyatomic ion. That's just a single nitrogen atom with a -3 charge. Carbonate, -2 charge. Phosphate, PO4 with a -3 charge. And then hydrogen carbonate or bicarbonate, same name, same formula, different names for the same formula, is HCO3, and that has a -1 charge. So we're going to treat these groups of atoms as if in a very similar way do we treat a single monatomic ion. These are almost going to behave like they're atoms in the way they combine, and they're going to react. In a lot of ways, they behave and move as a group in chemical reactions. So, where am I? So many of the compounds you'll come across are going to be made from polyatomic ions. Here's an example. Ammonium nitrate, you may have even heard that name. Ammonium nitrate is what we use in chemical fertilizers, and it's the presence of the nitrogen that helps plants grow. Plaster is calcium sulfate. And Here is a couple little things you might have to watch out for when you're naming. Again, you don't have to memorize these, but you're gonna see some patterns. And eventually, if you move on to take higher level chemistries, you will need to memorize them. So I'm just showing you some tricks to help you learn them. But for these exams, you're going to have access to a list of these names and formulas. But if you look at nitrate, it's NO3 with a -1 charge. Nitrite, ITE, has one less oxygen, but it has the same charge. It's just NO2 now with a negative charge. So the nitrate, to become a nitrite, we just took away one oxygen. See the similar thing with phosphate. Okay, phosphate is PO4 with a -3 charge. To get phosphite, we just take off one oxygen, becomes PO3 with a 3- charge. Now if I take a sulfite or a carbonate and I stick a hydrogen on it, the name itself becomes hydrogen carbonate or hydrogen sulfate. Or instead of saying hydrogen, you'll sometimes see bi put in front of the names. I know I'm showing a lot of rules at you. You don't need to memorize these. I'm just showing you examples.
So hydrogen is a synonym for bi?
Yeah, in this particular instance, when you're talking about polyatomic ions. Okay. You can't do this anywhere else, but when you're forming an ion, you'll sometimes see the hydrogen carbonate just be called bicarbonate. I have to look up the history behind that, where the naming comes from. So here are just examples of negative polyatomic ions, except for this one. This is the only really positive polyatomic ion. All the others in the list are negative. So these will come up in names. So then, where does that leave us? That's going to mean, how do we use these when we're writing formulas and names? So let's say I'm going to make a compound from a calcium ion and NO3, which is nitrate, a nitrate ion. Now, the name of this compound will be calcium nitrate. Okay, so the rule stays the same. We state the positive ion, we state the negative ion, and we put them together. Now, to look at the formula for this, I have calcium with a 2+ charge and NO3 with a -1 charge. So if I do the crisscross, I would need a 2 down here, and that is just a 1. Okay. So I need 2 sets of NO3, which have a -1 charge, to cancel out the calcium, which has a 2+ charge. So how do we write that? Well, we'll take a little trick that you've seen in algebra. When I want to have a whole group multiplied by 2, in algebra we use parentheses. That's what we're going to do here. I'm going to put the NO3 in parentheses, and put a 2 after it. Okay, so that indicates I have 2 sets of NO3. Now, you could say, well, could you distribute the parentheses and say CaN2O6? That is a formula that could represent the same compound. That's true. But when you write it this way, you kind of hide a little bit of the information, and the nitrate isn't as apparent. So we typically will write it this way instead to make that nitrate stand out. Okay. Does that make sense? Any questions on that? I will do some more examples, but I just want to see if any questions so far.
It makes sense, but I definitely need to see a few more examples for this to stick.
Absolutely. Okay, so let's do aluminum bicarbonate. Now, just switch back to the table. So bicarbonate, where is my, wrong one. Okay, bicarbonate, also hydrogen carbonate, is HCO3 with a -1 charge. So there's our negative ion, HCO3 with a -1 charge. And aluminum is just like all the other aluminums we've counted, it's always +3. Okay, so the name is just aluminum bicarbonate, positive ion, negative ion. So what would its formula look like? Well, if I put these together, okay, what do my subscripts need to be? Okay. Think about doing the crossing and pulling down the numbers. What number would be here and here if I do that crisscross?
So when you oh, sorry, go ahead.
So as I say, the aluminum would have the negative or the 1.
Right, and it's a 1, so we don't write it. We don't bother to write it. And how about the bicarbonate?
3.
3. And because we're adding a number outside to apply to the group, we need parentheses here.
So that was my question. So when you crisscross like a negative charge, it's positive. It becomes positive? Right,
because when we crossing, we're just telling us how many of each ion we need.
Mm.
Okay, so that's just a little shortcut that allows you to see how many of each ion we'll need. And if you see now when I combine these, I have 3 plus times 1 plus -1 times 3. That equals 0. Okay.
So the subscript 3.
The charges don't get pulled down. We're just looking at what the numbers of these subscripts need to be. These are always positive numbers because they're telling us how many of each we need. Okay, so it's a shortcut to allow you to figure out the subscripts when you're balancing charges. But our ultimate goal is to make sure that the charges add up to 0. So if you look here, there's our positive ion, there's our negative ion. The positive ion is 3 plus. The negative ion is 1 minus. So we need 3 of these combined with the aluminum to add up to 0. So that means our subscript is going to be a 3 here, and the aluminum would have a subscript of 1, but we don't bother to write in ones. So we're going to put a 3 here, but then again, we need the parentheses for whenever a polyatomic ion has a subscript. Now, if the subscript here was 1, I wouldn't bother to write the 1, and I wouldn't even need the parentheses in that case. Okay, so you only need the parentheses when you're adding a subscript here to apply the whole group. If you don't need the subscript, you don't need the parentheses. Okay, so here's just another example. Sodium sulfate. So sodium is +1, sulfate is -2. I need 2 sodiums and 1 sulfate, but if you notice here, I didn't have to add an extra subscript on the sulfate, so I don't need parentheses here. It's just Na2SO4. Okay, now iron phosphate. Now the iron is +3 because they tell you it's iron 3 phosphate. And if you looked up phosphate, phosphate's also -3. So +3 -3, the charges balance. So it's a 1-to-1 ratio. So it's just written as FePO4. Now the aluminum carbonate, aluminum is again +3. Carbonate is -2. So because now I do the crisscross, and so it ends up being a 2-to-3 ratio. And if you need to double check, 2 times +3 is 6, 3 times -2 is -6, which add up to 0. And so here, because I'm adding a subscript to a polyatomic ion, I add the parentheses around the ion and then put in the subscript. What are we doing on time? I think we're pretty good. So these are just a list of common polyatomic ions and where they're found in. You can take a look at that on your own. Okay, so naming the compounds is fairly straightforward as long as you have the sheet and you don't need to memorize them. So, but you're going to look for the positive ion and you're going to look for the negative ion. Okay, so the potassium, the manganese stand right out. And this one is obvious because you see the parentheses, so you know that has to be the ion, the OH. And I don't see parentheses here, so I'm going to assume that this whole group is my negative ion. Okay, and you'll find that most, with one exception, all the polyatomics except for one common one are going to be negative. Okay, the only one that's positive is going to be NH4, ammonia. But all the other polyatomic ions will be negative. Okay, so this one, if I look up ClO3, I'm going to find its name will be chlorate, and the positive ion is just potassium. So the combined name is just potassium chlorate. Now again, don't expect you to memorize them. So Mn is, anyone remember what Mn is?
Manganese?
Manganese, good. So manganese, and what is OH? Anyone remember? Hydroxide. So it's just positive ion, negative ion, manganese hydroxide. Okay. Oh, and I screwed up. I forgot the Roman numeral. Manganese is went too fast. Okay, manganese. If I look on the periodic table, manganese comes in two forms. It can either have a +1 or +2. So we gotta figure it out. Okay, hydroxide is always -1, and you saw we had two of them. So this has to be +2. The only way it would cancel out the -1 on the hydroxide. So then this name becomes manganese Roman numeral 2 hydroxide. Okay, so this is a good chart just to try to summarize all these different name conventions. But it's always going to come down to just name the positive ion followed by the negative ion. What all the complexity is determining what's the name of the positive ion, what's the name of the negative ion. So for the positive ion, it's either going to be a metal or NH4. That's the only positive polyatomic ion. So look for those. Now, if it's a metal, does it form more than one positive ion? So look at on the periodic table, if it's near the bottom of group 5 or in that transition metal range, need to double check to see if it can form more than one positive ion. So if it can form more, we're going to use the name of the element followed by a Roman numeral, which indicates the charge. Otherwise, we just use the name of the element. For nonmetals, we're just going to look at the negative ion. Is it a single atom ion or a polyatomic ion? Okay, well, if it's a monatomic ion, we just keep the name of the element and add an IDE ending. If it's a polyatomic ion, we just look up the name of the polyatomic ion and use its name. So these do take practice. So I would suggest when you do these, have a sheet, use the sheet that lists all the ions and their charges. Okay, and I posted it in the course materials. And let's see, the file was called Common Ions List. Okay. So that's going to give you the ions on the periodic table and the polyatomic ions. So, I'm going to name the following ionic compounds. Anyone want to take a guess at this?
So we have sodium and phosphate, right?
Right.
I'm not sure I know the rest, in all honesty.
Okay, well, so, okay, sodium and
Phide.
phosphide, right. It's phosphorus, name becomes phosphide. Okay. Second one, SO4. Anyone remember what that was called? Sulfate. Okay. It's on the list of common ions, so you just look for SO4. And SO4, it also will give you the charge. So we know Cu is copper. But copper, if you look on that sheet of common ions or that periodic table slide I showed you, copper can either be +1 or +2. So in this case, which one is it? Is this copper a +1 or +2 ion?
+2.
+2, good, because the sulfate's +2. So this is copper 2 sulfate. So you could have a copper 1 sulfate, but it would be, I would need 2 coppers for every 1 sulfur. So that would be copper 1 sulfate. Okay, and the last one. So ClO3, I'm sorry, ClO. ClO is our chlorate.
All right.
Chlorate, ClO.
Okay.
I'm sorry, hypochlorite. Hypochlorite. HYPOCLORITE. Hypochlorite. And that has a charge of -1. So Cr is chromium. And chromium can either be +2 or +3. Which one is it in this case?
3.
3, right? Because I have 3 hypochlorites, so that has to be 3. Chromium 3 hypochlorite. All right. So why don't we take a 5-minute break, see if you have any questions.